Welcome to PV Magazine webinar Rooftop and TOPCon, appraising the benefits of TOPCon solar modules on LCOE for distributed generation projects. My name is Emiliano Bellini. I'm an editor of PV Magazine and also the moderator of this event. I'm really glad to introduce immediately today's speakers. We have Walid Al-Lash, which is Business Development Manager for the Middle East and North Africa at Chinese module maker Jinko Solar. Hi, Walid.
Hi.
How are you doing?
I am very happy to be here, especially with you, because you have been very active in the TOPCon and type recently.
Yes, I've written a lot about this topic. Yeah. And where are you based?
I'm in Dubai.
Good. And now we also introduce Sebastian Mack, which is PV production technology researcher at the Fraunhofer Institute for Solar Energy Systems in Germany. How, Sebastian?
Hello, good morning to everyone.
Where are you based, Sebastian?
I'm located at Fraunhofer ISE in Freiburg, Germany. That's the southwestern part of Germany next to France and Switzerland.
So good to have you here. And now we will move to the webinar content. And before we move to the webinar's presentations, I would like to have a quick chat with both of you on how the TOPCon module technology is currently penetrating in the global solar market. Walid, the first question is for you. In our previous webinar with Jinko, we have seen how the TOPCon module technology is constantly gaining market shares in the large-scale segment. Can we say this is also happening for the rooftop segment?
It is actually, Emiliano, what we have noticed is that it is being used for the distributed generation sector much faster than the utility scale, because usually for utility scale, you know, there is much requirements as references and so for the bankability issues. But the market, the distributed generation market, just picked up very fast to a point where Jinko Solar decided to switch completely to the TOPCon and type by the end of this year.
So, I mean, you see big hopes also for rooftop for this kind of modules, right?
Without a doubt, especially in our region, Middle East, North Africa, we have harsh conditions like high temperature, humidity, and such modules have major advantages in such climates.
And Sebastian, the trajectory of this technology is relatively new. Can we say that there are already some visible signs of an unequivocal success of this panel technology?
Well, at least from a point of transition from lab to fab, it's definitely a large success. So when you think back to PERC technology, this was introduced in 1990 by UNSW researchers, and it came to the market like 20 years ago. And TOPCon technology was introduced in 2013, and 8 years or 9 years later, it's already being in production and being sold. So from a TOPCon point of view, I would definitely say it's a success story.
And Walid, we will often speak about rooftop solar today. Will we refer mostly to commercial and industrial installation, or will we also include residential PV in our discussion?
Basically, usually commercial, industrial, and residential are treated the same in terms of the selection of the module. What we see sometimes there is a difference when we go for solar pumping and agricultural applications. But without a doubt, like I know some people who have already signed to install these systems for their houses as well, apartments. So I believe we will be covering the entire sector.
So you mean it will also be possible to achieve higher LCOE with a small system, with a small product?
Definitely. Whatever the size is, it definitely have advantages that you cannot overlook anymore.
And Sebastian, we are also here to discuss the common belief that at least in these early stages, the TOPCon solar module needs scale to achieve a higher LCOE than PERC modules. Is this a well-founded idea, or is scale not so necessary?
I think scale is important. On the other hand, of course, also the location where such modules are being installed is important due to the irradiation. But on the other hand, of course, yes, you're competing with a developed technology PERC, and then of course questions of scale are important to compete with, because you're entering a market and you need to compete with the technology that is already in the market.
Yes, of course, in terms of prices, it's not so easy. And Walid, can we say that there are some markets that are better prepared than others to incorporate this technology? For example, mature markets provide a better ground for these products?
Definitely, Emiliano. It has been always the case. We have seen it from poly to mono. We have seen it from full cell to half cell. There is always markets that are more adaptive to new technologies. And usually, as you mentioned, the mature markets do. And also the application of a country or the application of a region plays a massive role. Like, for example, in North Africa or most of African countries, you see a lot of solar pumping. And for that, you do not require a very high advantage or high-tech technologies. So usually they are a little bit slower in adapting new technologies. But without a doubt, we have seen that mature markets like in the MENA region, let's say like Morocco, Jordan, Saudi Arabia, United Arab Emirates, even Lebanon, Yemen, the markets that have been slow in adapting new technologies previously are now always looking for what is new in the market. I think this has changed entirely all over the world, in my opinion.
So you mean also emerging markets are now representing a good share for these products?
True. If you notice, Emiliano, the life cycle now for technology or a model is becoming very much shorter because the adoption is becoming much faster all over the world. I think the people who switched from mono to poly, that process took, let's say, 3 years. I think from P-type PERC to N-type TOPCon, I think it's going to take almost 1 year or throughout the 2022 will be enough for at least Jinko Solar to completely switch. So I think overall, all of the markets are becoming much more adaptive to new technologies.
So as a result, is Jinko Solar scaling up capacities in China, right?
Definitely. We will talk about that.
Yes, we will see this in the webinar. Before we move to the presentation, my last question for Sebastian. Do you have an idea on what market shares TOPCon modules may gain in the years to come? Should we see this technology prevail on PERC or heterojunction, for example?
So as a new entrant into the market, we're at the moment in the low one-digit range of, let's say, 5%. But TOPCon will definitely increase in market share over the next years. And I expect it also to, depending how fast companies like Jinko Solar, for example, are migrating to TOPCon solar cell, to have at least a big chunk in the market and probably also be the dominating technology in the years to come.
Thank you very much, Sebastian, for the final question, and thank you for this initial chat to warm up our audience. Now we can move to see today's presentations. Before, just let me remind that the slides and the recording of the presentation will be available for download on our website starting from tomorrow. And let me also thank Beatriz Santos for organizing this webinar. Thank you, Beatriz. And now we can move to the first presentation, which is from you, Sebastian.
Yeah, so thank you for the kind introduction, Emiliano. So the title of my presentation is TOPCon Silicon Solar Cells from Pilot Line to Fab. Okay, so here the agenda of my talk. So first I will very shortly introduce the TOPCon technology, which all of you are already familiar with. I will then show you some results from our own pilot line. Next, I will talk about cost and approaches to reduce costs, and finally give an outlook what we might see in the years to come. So starting with the short introduction into the TOPCon technology, which is formed by the stack of the thin tin oxide layer of around 1.2 nanometers and the doped polysilicon layer on top. So the TOPCon technology was introduced into the market in 2013 by Fraunhofer ISE, and the TOPCon technology is shown here on the right-hand side in red, which is like industrial science. So this solar cell features front junction, so this means the emitter is placed on the front side, and we make use of an N-type silicon wafer. So the TOPCon technology was then introduced in 2021. This is here on the right-hand side with the green, highlighted in green. Here we use a P-type wafer, and here the TOPCon layer on the rear side serves as a rear emitter, and the RE stands is the acronym for rear emitter. So it's like the similar process flow with a similar layout, but we only use a p-type wafer instead of an n-type wafer. And our clean room guys were able to show conversion efficiencies of close to 26% with both of these architectures in the small cells of 2 by 2 centimeters square. So let's look what industry has been doing over the last years. And this, as many players are active in this field, I only want to give a short overview and not all of the informations about how the solar cells have been published, because this information I gathered from press releases from different companies and also PV Magazine. But what I want to highlight is that companies from China have been showing conversion efficiencies of over 25% with these solar cells, and all of these efficiencies have been independently confirmed by third parties, but on large areas. But as I pointed out before, not all of the technologies, such as for TOPCon formation or the emitter, are being published. So we don't know about what they did, but the results definitely are impressive.
So Sebastian, sorry, just say we don't know exactly what they did, how they achieved, because they don't want to disclose too many secrets. We all know this. But can we say all these cells are, let's say, related to the concept proposed by the Fraunhofer ISA, right? Are they all, let's say, almost the same solar cell?
Yeah. So the solar cell is more or less always the same. So like highlighted here on the left side, we have an n-type wafer, we have a front junction limit on the front side. We typically have screen printed contacts, but how the actual layout of the solar cell then is being done in detail, this was not disclosed. But definitely the efficiencies that have been, the 25% efficiency that has been shown by UNSW many years ago has been active for a long time as an efficiency record. And now these records have been pulverized by several companies on large area wafer. So this is definitely an impressive result.
Which means there is potential to further raise this efficiency.
Definitely, yes. And although these results have been achieved as claimed in pilot lines, I think also production equipment has been used, and now it has to be shown how these lab record efficiencies can be transferred into production. But everyone is doing a great job, so I think efficiency will go towards these values that we see here on this slide.
Thank you, Sebastian. And please go ahead with the presentation.
Thank you. Now coming to the second part, the results from our pilot line. For example, here, this is a screenshot from our virtual tour through our PVTech front-end laboratory, and I put the link on the slide here at the bottom. So you can either search for it in your browser, or you can take this then from the slides when they're available to also walk around into our lab. So we have like all this production tool here in our front-end lab. And here on this slide, you see an exemplary process flow, which we use for fabrication of such TOPCon cells. So we have some wet chemical processes in green. We have some high temperature processes in red. We have some passivation processes in blue, and we have some screen printed metallization. And this is like more or less the standard process flow with small adapting depending on what kind of tools you use in your lab. Here, as the LPCVD technology that we use for the deposition of this doped silicon layer is not a single-sided process, but a double-sided deposition. We need to remove the polysilicon on the front side, but we don't want it to have, we don't want it to be in the solar cell, and we remove it here by atmospheric dry etching, but also wet chemical processes can be used. At the moment, we use M2 wafers. We are able to upgrade our lab to M6, but for larger wafer areas, such as G12 wafers, we would need to replace some tools, and this is something that is in process. And of course, we are ready for samplings if someone is interested for this. Now, looking at the different technologies that are being promoted for deposition of these TOPCon layers here, I want to highlight 5 different technologies. So 3 are CVD, so chemical vapor deposition processes, mainly LPCVD, plasma enhanced CVD, and atmospheric pressure CVD. And all of these technologies come in hand with different technology readiness levels. And the dominant technology in the market at the moment is LPCVD, which it's in mass production. We put it in technology readiness level 9 because it's a dominating technology. But also Jollywood, together with its partners, have the process running in mass production. And although it might not be the dominant technology, it is definitely on a very, very high technology readiness level. And some other technologies like PCVD or APC are, as far as we know, not in industrial production so far. That's why we put them in 5. And some new technologies like liquid silicon or evaporation are definitely still in a clean room environment and not in production.
Sebastian, a quick question, just to have an idea. The 4 cells that we seen in the previous slide were all produced with LPCVD, right?
You mean by the different companies?
Yeah, they're all relying on this kind of equipment still with the Jollywood, Trina, Jinko, and Longi.
So
I know we also see there is another.
Yeah, so based to what I saw in different publications, initially Jollywood was using LPCVD, but lately they migrated to their so-called POPA technology, which stands for plasma oxidation and plasma assisted in situ doping, which is like a PVD process. So they made the transition from LPCVD. So they seem to have made the transition from LPCVD to a PVD process due to, for example, single-sided deposition.
Okay, and for Trina and Longi, this is still unknown. Maybe they have likely used the LPCVD, but this is unclear, right?
Yeah, at least it's not explicitly written here in these press releases. So
okay,
so I didn't know exactly, so I put a question mark.
But this remains the dominating technology you said before, right?
Yeah. Yeah.
Okay. Thank you, and please go ahead.
So now looking at some results from our lab, here on this slide, I want to focus on the bifaciality of such solar cells. When these solar cells, these TOPCon cells are being illuminated either from the front side, which are the black arrows here on the front side, or from the rear side, which then corresponds to the red dots in this plot. And when looking at the external quantum efficiency, when the cell is being illuminated from the rear side, we see like no quantum efficiency in the blue wavelength regions. And the reason for this is we have quite a high absorption coefficient in polysilicon. And here, these quantum efficiency are for polysilicon thicknesses of 80 nanometers. And when we then calculate the bifaciality as a ratio of the power output or efficiency from rear side divided by front side efficiency, for this 80 nanometer polysilicon layer, we end up with a bifaciality of 84% versus air. And if we increase the polysilicon thickness to 160 nanometers in the same experiment, we reduce the bifaciality to already only 78%. Nevertheless, both of these bifacialities are at least in the range or even slightly higher than for the competing PERC technology, where we find bifacialities of typically 70 to 80%. And these low quantum efficiency or spectral response in the blue area is definitely not that severe when we put these cells into modules due to the UV cutoff in the solar line glass or the rear encapsulant. And we, by beginning of last year, we made some solar modules with a bifaciality of 85%. So this is for the module, whereas these bullet points above are for the solar cell versus air. So there's definitely also a high bifaciality for the solar modules. Looking at the champion results in our lab here for this 80 nanometer polysilicon layer, we were able to make a completely in-house process with an efficiency of 23%. Of course, this is a calibrated measurement by Fraunhofer CalLab using a grid touch unit here with 30 wires for the current. And due to the very effective edge isolation in the ADE process, we also have a very low reverse current density of only 0.1 milliamps per centimeter square at minus 12 volts, which means the solar cell is definitely also compatible with a solar module assembly. Now in the third part, I want to talk a little bit about cost and related approaches to reduce cost. Some years ago, we made a calculation for different production lines for bifacial PERC, for different routes for TOPCon using APCVD, PCVD, LPCVD with more processes or low processes in the production sequence. And we assumed similar uptimes and yields for all of these production lines. And then we not only calculated the cost and the cost of ownership, but also we calculated the cost down until LCOE to compare how these modules would then compete in the field. And here we chose a location in Southern Europe with an irradiation of 1,700 kilowatt hours per square meter and year. And we found that we need like an efficiency increase of 0.4 to 0.6% absolute versus PERC to end up with the same LCOE. Of course, if the efficiency gap is higher, then we also end up with lower LCOE compared to PERC.
And Sebastian, sorry, just a question. Of course, we're talking about a higher efficiency. Does it mean that this efficiency is fully able to repay the higher production cost?
Definitely. It's not only for premium products, but also on the other hand, you have a balance of the BOS cost, and you have like cost for the frame, for the glass, for the encapsulant, and you also can allow for higher cost increases than for efficiency increases due to all these related costs.
But of course, I mean, the PERC has also a role in this situation. I mean, if PERC will be able to further reduce costs, this would be a problem for the TOPCon technology.
Yes, of course, if PERC goes down in cost, then also a TOPCon has to go down in cost. But due to the reason that TOPCon is rather a newer technology than PERC, also with new technologies being implemented into the process sequence advances with the tools, and we also expect a faster decrease of cost for the TOPCon because it's still a new product and more things are being developed for this.
And possibly TOPCon technology also has to reach some scale in the industry, in the manufacturing capacity, which is still not there.
Yeah, so this is one of the reasons. On the other hand, also the N-type wafer is still a little bit higher in cost compared to the P-type wafers. But then if more N-type wafers would be produced, then also the cost of this N-type wafer would go down, which would directly translate to LCOE for that TOPCon module.
Thanks, Sebastian.
Welcome. So let's talk a little bit about cost. And we already shortly addressed the N-type wafer being a little bit more costly. But on the other hand, as I've shown you also in the slides, the solar cell that we produce at the moment features screen printed silver and silver aluminum pastes on both sides. And when looking at the cost of ownership, cost for the metallization, we already see a large difference between the PERC module and the TOPCon module. And the reason for this is the use of the silver paste on both sides of the solar cell. And what one has to keep in mind, so this is I took this out of a presentation from Brett Hallam, that at the moment we already, PV production already consumes 10% of the silver world production. And if we translated this now to a TOPCon technology with 100%, we would already increase the silver consumption by around 60% relative. And if the PV production globally increases over the next year, which is expected also to address the climate change, scientists and engineers definitely have to think about how to reduce the silver consumption. Otherwise, a dominant part of the silver world production would be used for PV, and this is definitely not something that would be a wanted development. So how can the silver consumption be decreased? We propose, for example, to replace the silver screen printed contacts also by plated contacts. And the advantages for this are, for example, you can, on the one hand, reduce the shading of the solar cell. Here, for example, this is a nickel copper plated contact with a thickness with a finger width of only 50 microns, which of course then translates to higher JC or VOC. The TOPCon interlayer can reduce the VOC loss due to metallization. You can end up with high fill factors anyway because you have low contact resistance. And what is most important, you can really reduce the silver consumption by 90%, give or take. And it could also be lead-free. And of course, this can also come in hand with the decreased cost of ownership. Even when you look at a different window for the silver cost, how it has been evolving over the last few years. And with this plated contacts, you can definitely decrease also the cost of ownership on wafer level. And this also can be combined with high efficiency. So this is, for example, then a solar cell result with plated contacts on both the front and the rear of the solar cell. For this experiment, industrial precursors have been used, and the back-end processing was done at ESA. And we were supplied also reference samples with screen printed by the supplier, and with a polysilicon thickness of 125 nanometers, we were able to show an efficiency delta of 0.5% absolute, with efficiencies of 24% and a high VOC of 750 millivolts. So nice results on this. So let's look what will happen in the future, or what might happen in the future. Here I want to point out two figures from the actual ITR PV. The first, on the upper right-hand side, concentrates on the world market share of these different solar cells. And this TOPCon technology here in 2021 did feature a market share of around 5%. And within this next 10 years, until 2031, the market share is expected to increase tenfold until 50%. So TOPCon technology is expected to increase in market share. On the other hand, we already just talked a little bit about the TOPCon cell and the use of this P-type wafer. And this is also expected to increase. For example, this yellow part here in this column corresponds to the N-type wafer with TOPCon technology, and the light blue corresponds to the P-type wafer with TOPCon technology. And you see here, this is like not existent, and it will increase over the next years and probably might also end up with something like 10% market share. On the other hand, I think the throughput of the polysilicon process will increase by new developments, which will allow to lower the required thickness of this polysilicon layer. We will increase the capacity per run within each of these tools, and also novel equipment will enter the market. For example, in the lower right-hand side, dominant technology, as I pointed out before, is the LPCVD technology with a market share of initially around 90%. And the yellow part then corresponds to competing technology. In the ITR PV, this only corresponded to PCVD, but I was free to extend this by APCVD and PVD, which I think could also be very important technologies, and due to this possible single-sided deposition will probably also increase in market share. We already talked a little bit about silver metallization being a cost driver, and I've shown you some results from ESA, but also there was a very impressive result by an Australian startup which used solar cells from China, so industrial precursors, to show an efficiency of 25.5% absolute, so very impressive results. On the other hand, there's also an interesting approach to replace the silver aluminum paste on the front side by screen printed aluminum paste. And what people don't have in mind is that these passivated contacts that we talked about could also path the way for new applications, such as, for example, tandem structures. And let me just show you 2 more slides. So one exemplary application could be a PERC solar cell, for example, here in the upper part, on which you place a perovskite solar cell on top. And then you could have either full area, TOPCon intermediate layer, or you could place it only locally. And so different approaches and ideas how this could be done. On the bottom side here, the TOPCon layer consists not of a polysilicon layer, but a silicon carbide layer. This is a presentation by Gisem Lugai, which also then used a crystalline silicon bottom cell together with a perovskite solar cell on top and showed an efficiency of 25%. So very impressive results here, but also ESA also wants to do something different, and here we combined a silicon bottom cell together with 2 3-5 solar cells on top, and we did have TOPCon layers on both the front side and the rear side of such solar cells, and we were able to show efficiencies of 36% here in this case due to the triple junction layout. Yeah, and that was my presentation. So thank you so much for having me and for letting me show these results to you.
Thank you, Sebastian. Before you leave, just one question, because you cited silver as a potential issue. I mean, silver prices are also on the rise, or as other precious metal prices are all rising in this difficult crisis. Do you think it will be more likely that use consumption will be reduced in TOPCon, or that we will see probably a larger supply from the silver industry?
Good question. So on the one hand, scientists and engineers definitely were able, together with the great work that the paste manufacturers have done over the last 15 years, to increase the silver finger width a lot over the years. And I think this trend will continue. Silver consumption anyway will decrease, but yeah, the PV production has increased a lot over the last years, and I think people now really think about silver consumption, and plating might be one way to address this and reduce the silver consumption a lot. So I think the window for plated contacts is definitely opening again.
But it will take some years, right? We won't see a quick transition to, let's say, silver-free TOPCon modules or let's say other metallization techniques.
Well, I'm not working for a cell manufacturer, but I think if you have already a PERC production and you want to migrate to TOPCon, then it might be easy just to stick to screen printers because you have them in your line anyway. But if you open up a new fab and you start with grass, then also plated contacts might be interesting because you have to buy the tools anyway.
Thank you very much, Sebastian, for your presentation and for these final answers. I will now move to Walid's presentation. And stay with us for the final round of questions and answers.
Thank you, Emiliano. Thank you, Sebastian. A lot of information. Fraunhofer is doing an amazing job, as we all know, in the TOPCon, and we appreciate being with us. I am going to try to be direct in order to have as much time as possible in open discussion. Just an update for everyone. We are very proud to be the first company globally to achieve 100 gigawatt of shipped modules. We did that by the end of Q1 2022, having upgraded our annual capacity for over 40 gigawatt for this year. As everyone knows, we are distributed globally very well, and we are very proud of having the leading market share in 7 out of the biggest 10 markets globally. We are talking about the USA, Vietnam, Japan, Germany, Australia, India, and the Netherlands. And we are extremely proud with our global existence. And this actually makes us closer to a global approach in the industry, as we are almost everywhere. As everyone knows, we do manufacturing fully integrated way, which means that we start from the wafer, cells, panels, and we have added a new product, which is the building integrated photovoltaics, which we are supplying now, the biggest project in the world in Dubai. As part of the transition that Jinko did in the past few years, that we are going now into providing full turnkey solutions. We have added the solar lighting, energy storage systems, pumping solutions as part of what we offer to our client. And this is all, of course, without ignoring the fact that we are a manufacturer, a PV module manufacturer. And I still remember one of the very first modules that I bought in 2012 was a 300 watt module, which was the first, the beginning of the transition from 60 cell into 72 cell modules, and it was a 300 watt. And now if we look out the years, poly to mono, full cell, half cell, wafer sizes, number of bus bars, and most recently P-type to N-type, this is showing how fast this industry is growing, and we are extremely proud to be one of the leaders helping providing or publishing our new module, which is the Tiger Neo. Tiger Neo is our N-type TOPCon module. Now we're going to just discuss the technical advantages that this module is offering to the market now. And of course, we're going to discuss the impact financially of these technicalities. As Sebastian said, I'm not going to go into the technology a lot. They are the masters of this technology and the research about this technology. This is an improvement of what is an already existing technology, which is the PERT. And as he mentioned, this technology is still at an early stage, and we believe there is a huge room for improvement, and which means that I think that the scale of development in this technology is going to be very fast to a point where PERC, I don't think, will be able to stand up in the face of this development. And I always use this example, the transition from polysilicon to mono or polycrystalline to monocrystalline is being repeated now, even if the price gap goes a little bit wider as it did recently, but still the N-type, we believe, is going to pick up rapidly in the upcoming years. We are very proud that we have achieved 3 world records in the second half of 2021, and I see Emiliano, your name is on the announcements for PV Magazine in June, July, and it's Mark in October. And again, this is just a span of few months, and you can only imagine with the progress that is happening, maybe the limits are very far from what we are offering today.
And what do you believe could be the limits for this technology on an industrial scale, of course, not at laboratory level?
I don't think there is a limit for technology. To be honest, in our industry, I think it's always a discussion of which technology. Usually, the options that are coming up are now they are much more than the options that were in the past. I think for the first time in years or ever, we are looking at different companies providing completely different technology at certain points. We see some companies adopting the heterojunction, some companies adopting the TOPCon N-type, some companies actually adopting the TOPCon P-type. So basically, it's about what every single technology can add to the table. And after all, we are now in a race to achieve the cheapest electricity in the world, as we have been seeing it in the past few years, especially in the MENA region. Every single big project is expected to be a new world record in terms of tariff. And this competitive atmosphere is definitely pushing the industry to the extreme.
At the same time, there must be a balance between, of course, raising the efficiency and maintaining low production costs. I mean, it's always difficult not to increase cost of production while reaching higher efficiencies.
Definitely. And I think this is why TOPCon now, we are talking about TOPCon, because TOPCon has been in the lab for many years. But what happened is now we have managed to reduce the gap in pricing or the premium added. And I'm not going to give out prices, but we are talking about less than 5% in initial cost for solar modules, which is very, very tempting to go to, especially if you can get 3, 4, 5% extra production every year. If you can do a simple math calculation in your head, it makes complete sense to do the switch.
Thank you, Wally. Please go ahead with the presentation.
Thank you. So for the advantages of the Tiger Neo, one of the main, and I think one of the great advantages that have pushed this industry to be adopted very fast in the industry of this technology in the industry is the annual degradation. We are talking about a first year of degradation of less than 1% when it was 2% for the P-type. And we are talking about a linear degradation of 0.4%, minus 0.4% annually for 30 years. Until 30 years, compared to 0.55 for our P-type monofacial until the year 25. So after 25 years for P-type, we are talking about a guaranteed of 84.8%. But for N-type, we are talking about 87.4. And if you calculate the extra amount of energy that you're going to get throughout these years, it doesn't matter from year 1 until year 25, or the extra 5 years that we are adding on top of our production warranty, it adds up to becoming a very vital and important circumstance of comparing. And the other one that is really important, especially in our region, we are talking about high temperatures most of the year, and we have managed to offer a maximum of minus 0.30% per Celsius for the new Tiger Neo N-type compared to minus 0.35. And I believe this is going to have an amazing impact on the performance, especially if you look at, of course, the higher the temperature is, the more the difference is going to be at if we go for maybe 70, 75, 80, 85 Celsius for the cell, which is actually not very unlikely to happen in the, especially in the Gulf region here in the summer. We are talking about more than 2% of extra power for the module, which is going to extremely add up if you consider the size of the utility scale projects, of course, and also for the distributed generation, it's going to have a very good impact in the annual generation of electricity.
So so it's not only about higher efficiency; it's also about a better temperature coefficient compared to PERC.
Definitely, Emiliano. I think the impact or the major impacts that impact the levelized cost of energy are components that are not directly related to the efficiency, because for the Tiger Neo, our module is only 15 to 20 watts higher than the Tiger Pro. So that's not a very huge difference, but still, if you consider the performance of the module based on the degradation of efficiency and the temperature coefficient and other things that we will talk about, this is where the true value of TOPCon comes.
Yeah, exactly. So it's both are contributing, but probably temperature coefficients is a crucial factor improving the LCOE over a longer lifetime of the project, right?
I believe so, and especially in our region, again, because it's a hot climate, and such small differences can have major advantages over the lifetime of the project.
So my question would be at this point, if this module also makes sense at higher latitudes in the close to the poles eventually, or it's just a product for very hot climates, or let's say close to the region with high solar radiation?
I think it is a product that has advantages, many types of advantages. It's not about only temperature. It's about degradation. It's about reliability. It's about low light sensitivity, which we are going to talk about. So, but of course, some advantages are going to be more important at certain regions. And in our region, without a doubt, temperature coefficient and annual degradation, in my opinion, are going to have the two major impacts. But without a doubt, using this technology, because it's better in almost everything, is going to be an advantage no matter where.
So, I mean, market shares may be higher in the future in those markets with higher temperatures or higher solar radiation.
Well, this is what we thought, but to be honest, Emiliano, Europe has been extremely focusing on the Tiger Neo. At Jinko Solar, there is a massive demand for the new modules, and I think again, because maybe it's not just temperature. If we go for low light degradation, low light sensitivity or performance, if we go for reliability over time, if we go for all of these other factors, I think this makes this module popular almost everywhere, but for different reasons every place.
Thank you very much, Walid, and I invite you to go ahead with the presentation.
Thank you. The other one is the bifaciality factor. As Sebastian said, we have improved our average bifaciality factor from the P-type from 70% to our N-type to an average of 85%, which means directly, if you take this into consideration in the generation directly, we are talking about extra 2%. So if you talk about 2% here, 1% there, 2% there, we're going to come out with a really decent improvement in performance overall the lifetime of the project, without a doubt. The other one that is really fascinating, which is the low light performance, and the difference, of course, the less light there is, the bigger the difference. And we have seen that these modules start operating earlier in the day and stop generating electricity later in the day. They perform much better in cloudy days. And without a doubt, this is another reason why these products are also popular outside the Middle East and North Africa, also popular in Europe, for example, or North America. So there are many advantages, and we can have the final advantage that actually came up once we were doing the testing for the certification. As you know, now companies do the IEC, double IEC, triple IEC. When we did this kind of analysis, we have noticed that the reduction of efficiency or the effect of the test is less shown on the N-type than the P-type, which means that the N-type modules are more reliable and they are expected to live longer, which makes sense because we are offering 30 years for our monofacial product compared to 25 years for the P-type. These and, of course, many other advantages have pushed Jinko Solar to be one of the leading companies in proposing the Tiger Neo modules. As you can see, we have many options: the 54 watt, the 54 cell, 60 cell, 72 cell, and then we have 78 cell for the bifacial as well for utility scale. But if we look at case studies, and this is maybe something because I'm from an EPC background. Usually I like to put things into numbers, and we like to all look at things into numbers. We have done this simple analysis. I'm gonna talk about 3 projects very fast. I know I don't have a lot of time, but the first one is a comparison between the 540 watt and the
sorry, take your time. This is very interesting. So take your time to do this very quietly. No worries.
All right. So basically, this is a 152 megawatt project. It is a bifacial using 2P single axis tracking system, and the tariff is a little bit higher than $5. And if you look at that, there are 3 columns, as we can say. The last one on the left is the Tiger Pro 540 watt. And we have done something that we have built the same project with the same capacity. So we had to reduce the number of modules to have the exact same capacity using our 555 watt. And then we did something different. We completely did equivalent BOS in order to be able to judge the project from a different perspective. So we used the same number of the modules, the exact same design, the same cablings, the same BOS cost completely, and we switched to the 555. So of course, the power of the project was higher. If we compared it, if you compare the details here, we are talking about almost 3% extra generation when we switched for the same capacity using the TOPCon modules, and we are talking about more than 6.4 extra generation when we switched the type of modules. And if you go for the BOS, of course, you can see that there is an advantage of almost 2%. Or more than 2% at certain times. And this shows that if you look at the IRR of the project, there is a significant improvement in the IRR. We are talking about more than 0.3%. And of course, taking into consideration, we have actually added the module prices that were taken into consideration. We are talking about a little bit of more than 1 cent per watt increase in price. Still, the project makes more profit and have a better internal rate of return.
But still, we can consider this as very slight increase in price. I mean, it's 1 cent in the end when we have so much higher yield. I mean, it's not so much more expensive. I mean,
True. It is without a doubt. To be honest, again, we work with the utility scale a lot, and utility scale companies are very aggressive in terms of levelized cost of energy. And every single time they do any kind of homework, they go for the N-type. It makes complete sense for them because it is without a doubt the premium that you pay in the beginning pays off really, really quick sometimes. It depends, of course, on the tariff. I have another example that we will talk about after this one, which is in Palestine, because electricity is very, very expensive. Payback period is crazy for the extra investment. I'm going to discuss the Oman one now because it has high temperature, and also these are the two modules that I'm going to take into consideration. We are comparing the Tiger Pro 545 watt and the Tiger Neo 560. As you can see, the different in basic specifications, as you can see. And then we have taken this case study next to the international airport in Muscat. We had an area that we could fit 2,700 units or 2,700 modules, an AC capacity of 1.5 megawatt. We have went with the ideal circumstances in design, so almost a tilt angle of 20 degrees, an azimuth angle of 0. We have assumed a completely equivalent BOS costs equal, and of course we have assumed an additional premium for the modules for the N-type. So it is a very realistic simulation, and the electrical tariff is almost 30 Omani Biza, which is almost 7.8 US cents per kilowatt hour. After we ran this simulation, it was obvious that the Tiger Neo wins in every single aspect. In terms of DC capacity, we managed to put 2.7 more, so 1,512 kilowatt peak. In terms of annual yield, we have done more than 5.8% and in annual yield. In specific production, if we're talking about per kilowatt peak year, we are talking about extra 2.9%, and we had an improvement of more than 2.3% for the performance ratio. And this is, of course, using the simulation of a PVSys software using the third-party accredited PAN files for the modules. So if you convert all these technical data into money, you see this big table that we're not going to focus maybe a lot on. If you compare the Tiger Pro, Tiger Neo, the difference, and as you can see, the difference in generation starts as 5.8 almost, and then it becomes wider and wider because the degradation of the Tiger Neo modules is better than the degradation of the P-type. So we reach after 25 years, the difference is more than 9.7% in generation, and of course in revenues, because we are talking about a project that generates money for 25 years. Add on top of that, after 25 years, the P-type is no longer guaranteed in terms of generation, but the N-type has an extra 5 years that you can assume and build a financial case accordingly. And when we did this table on a comparison graph, we have figured out that switching from the P-type to the N-type, using all of the previous details that we have mentioned, the project, of course, covers the premium that was built for the modules and also generates an extra profit of more than 320,000 US dollars. And this is, again, a very, very realistic simulation done by one of our partners in Oman. If you do the same example, which is a project that we have signed very recently in Palestine, in Gaza, and the comparison was between 545 and 565 watt for the Tiger Neo. So the difference here is 20 watt. This was the availability that we offered. And if we do the exact same homework, you will see that also the DC capacity is increased by 3.7%. This was an east-west simulation. It was a corrugated sheet roof. So we have an extra 2.1% in specific production, an extra 1.8 in performance ratio. If you put that into money, having into consideration the fact that each kilowatt hour costs almost 35 US cents because it is now generated from diesel generators, and diesel is almost 1.5 to $2 per liter in Gaza. You took into consideration the entire cost of the project is something around $80,000, and the extra profit from switching from P-type to N-type is almost $87,000. So basically, the extra profit generated is 100% equivalent to the initial investment that was done. And this shows that the gap or the outcome of the switching to the N-type is definitely always related to the tariff, to the location, to the design circumstances. It can vary, but we chose one project in China, we chose one project in the Gulf, we chose one project in the Levant area, and every single time it makes complete sense financially to switch to these products. That would be all from my presentation, Emiliano.
Thank you so much, Walid. This was really interesting. I will come back again to the silver issue. I mean, probably you can give us another point of view from the industry. Is this becoming a real problem for the TOPCon technology? Because we know it's on both sides, and it's more and more silver is needed. Do you see any issue in the months or years to come for silver supply?
As Sebastian said, when you are switching from PERC to TOPCon, it makes complete sense to keep the entire process and do not change the process. And this means that, of course, as mentioned earlier, silver is becoming more and more of a concern in this industry. But what I have learned, Emiliano, I have been in the industry for only 10 years, but even during these 10 years, I have seen the industry overcoming such challenges, especially when the challenge has a financial impact. So you see that companies work really hard trying to avoid that issue. I believe in all of the expansion that is going to happen in the industry and all of the new production lines, there is enough research to show that there are very promising techniques to replace silver. And I'm not actually, I use Fraunhofer reports usually for that, so I'm not gonna overstep on Sebastian. But I think that this problem is not going to be an issue in the upcoming years because I believe the industry will be able to overcome it.
Yeah, well, among other supply bottlenecks that we are experiencing at the moment, so it may be challenging, but for any PV technology in the next years. So maybe Sebastian, if you want to come back with us, because now we have a round of questions and answers, and there is a first question I would like to submit to both of you, which is very interesting. Are current industrial producers of TOPCon using Fraunhofer ISO licenses? I don't know who want to answer. Maybe you can both answer this question. Sebastian.
Maybe Sebastian, you can go. I do not have a direct answer for this question. Neither do you.
As far as I know, I think Fraunhofer might do better in licensing technologies.
Yeah, which is a let's say an explanation, clear explanation. Another question about manufacturing. This is also for both. Are there preferred encapsulant materials for TOPCon modules? Maybe Sebastian, just start with you again.
Yeah, so I think for new modules, I think glass modules might be interesting, and in which you completely can get rid of all the encapsulants like EVA, so which would then give you a higher bifaciality. So recently also these polyolefins have gained interest in the module for the module producers due to a higher transparency, for example. So this is also something that might be interesting for these TOPCon modules. Well, I think everything that helps to get up the efficiencies and the power output of these modules is being interesting for the industry.
And Walid, maybe you want
as long as it's not very expensive, Sebastian.
Yeah, okay.
Of course, we are always hammered with providing, always we needing to provide at a very competitive price. Without a doubt, I think the industry, not very recent, not just because of the N-type, I think the industry have started to switch to the POE instead of EVA recently, especially, as Sebastian said, especially for the bifacial dual glass modules. And I believe it is without a doubt going to be a mainstream in the upcoming time for the TOPCon N-type.
And there is another interesting question about operation and maintenance. Are these modules somehow improving O&M costs? Can they help optimize O&M costs in installation?
I am trying to think. I don't think they will directly affect the operation and maintenance, but the fact that the modules are more reliable and basically you can see that the degradation of the efficiency is lower, it's going to affect the operation of the project as a circumstance, but as an effort needed to be put in the operation and maintenance, to be honest, I cannot think of anything extra that could happen from the switch.
Sebastian, do you have any suggestion on this topic?
I don't have any information on this, and it's also for me hard to imagine why for TOPCon it should be different to other modules. I mean, on the outside it's glass.
And Sebastian, maybe I want to ask you the same question I asked Walid before. It's about the contribution of the temperature coefficient and a higher efficiency, which is let's say the balance between these two contributions in the module.
Mm-hmm. Yeah, so definitely for all of these products that are targeted for being placed in locations with a high temperature, it's definitely beneficial to use products with a high VOC. And of course, then in this point, the TOPCon module and the TOPCon solar cell can really give you the advantage that you need, because you do the inherent lower temperature coefficient that come in hand with this higher VOC products. So it's also, so we did also some calculation years ago for PERC, and when it was still competing versus the aluminum back surface field solar cell. In that time, we already saw the advantage of the PERC module in regions with a high temperature, and now the same advantage now applies to the TOPCon module. So yeah, it definitely makes sense to use TOPCon modules in this MENA region.
And Wally, there is another question, of course, about rooftop, because this is the topic of our webinar. How small can a rooftop PV system be to host TOPCon modules? Can we see a 3 kilowatt installation, for example, being?
I already have seen almost 3 kilowatt projects being installed. Especially sometimes, I think this is where the efficiency becomes much more important again, because most of the rooftop suffer from limited area where you need to add as much power as you can on the roof of your building. And this is something that we have always been discussing, especially the fact that Jinko Solar did not go for the 210 wafer size, that you don't always have to go to the bigger size of a module. You have to focus on the efficiency of the module. And this is what we have been working on. This is why from the 182 PERC, we have switched to the 182 TOPCon. And we believe because of the efficiency factor, TOPCon is going to become adopted more and more for even very small residential applications.
Are you already seeing big demand from the residential segment?
I cannot explain really, Emiliano, how massive the demand is, and it is without a doubt bigger in the distributed generation, commercial, industrial, residential than it is in the utility scale so far.
And a question for you, Sebastian. How is it possible to adapt a PERC module line to the TOPCon technology, and how much would it cost for a manufacturer?
Good question. I'm not the one that has to buy all these tools. So of course it's possible to migrate from PERC to TOPCon. You need some extra space for the additional tools. You need at least one additional furnace for this TOPCon deposition. You need most probably, or you might want to have one additional tool for wraparound removal and possibly edge isolation after TOPCon formation. And depending on how the fab looks like, you might also need an additional tool for the high temperature anneal. So this depends a little bit what your PERC structure looks like, but you need a little bit of extra space. But you could also upgrade the tools that you already have. Like, for example, if you run phosphorus diffusion, you can just exchange some parts within the furnace, and then you could switch directly to boron diffusion. So this is nothing difficult. So this can be done quite easily.
Walid, was it easy for Jinko to switch from PERC to TOPCon?
I don't think it was easy to, I don't think easy is the right word to describe it. Of course, it took a lot of work to do this transition and yet still have that premium that we just mentioned, which is less than 5%. But I really think if we look what is available now, Jinko Solar has the highest available capacity for TOPCon N-type globally. And of course, we believe that this is going to be the beginning of the transition. And without a doubt, this is the major advantage for TOPCon over heterojunction. And this is why we are going to see TOPCon being commercialized in bigger scale before heterojunction does. It is not easy, but we are the best in what we do, Emiliano.
So, I mean, so you see no problem from the heterojunction industry. I mean, you don't see this as a real competitor, at least in the short term.
Well, there is always other technologies that are being developed in the background. And I'm not saying that Jinko Solar is not interested in heterojunction or did not do anything in heterojunction, but we believe, just like the fact that we believe that the growth of the wafer, we have explained it a lot previously with PV Magazine, the development switch need to make sense. The bigger wafer size, we didn't go from 166 to 210 for a reason, although we are able to do that with the same production lines that we have. But every transition, every step in the industry need to be fully studied, especially with the fact that the market is extremely competitive. One small mistake in your strategy, I think, can push the company 2-3 years in the back. Jinko Solar is actively doing research and development in the perovskite, if you're familiar. We have seen some very fascinating numbers, but that does not mean that we are going to have this product available now. So without a doubt, we understand the great potential of heterojunction as well, and everything remains on the table.
And Walid, sorry, but I have to ask the same question in all my webinars because it's always about prices. And our participants, they all want to know about prices. So how much are this module more expensive than conventional PERC modules? I know it's impossible for you to give some exact numbers, but maybe you can give us a range or a kind of idea of what kind of premium they have to pay for these modules.
In the first quarter, we used to offer 5 to 7% premium. In this quarter, we reduced it to 3 to 5% premium only.
And you think it will possibly go down?
Obviously, it is. And I believe this is why Jinko Solar is expanding the production every day. We wake up and we see that Jinko Solar decided to have more transition into PERC. We started with 8, 10 gigawatt, now 15 gigawatt this year alone, and who knows for next year. I believe that the gap is reducing to a point where maybe it will not make sense to produce PERC anymore.
Let's see. We're all excited about this future competition. I think our time is over, unfortunately, because it was so interesting and we had so many questions to answer, but I think we have to close now. Before we close, Sebastian, maybe you want to make your conclusion on how the TOPCon technology will perform in the next months or years or decades?
So my feeling is we're already at above 24% efficiency of solar cells in production. I think this will increase to over 25%. So the learning rate has been quite constant with 0.5% give or take efficiency increase per year. So this means probably the lab record efficiencies that we have seen of over 25% might be seen in production within the next 2 years. And but at one point, I think TOPCon will saturate. Maybe this is in the 26% range, but then on top, people are already thinking what could come next. And maybe it's the TOPCon bottom cell, which is then being combined with the top cell. So I'm quite optimistic about TOPCon in production.
But still 26%, it will be a great achievement. I mean, I think it could change the industry. So let's hope you're right. Walid, maybe you want to conclude?
My conclusion that I always say in such events, webinars, is that it is extremely important to evaluate the lifetime cost cycle analysis rather than the initial investment needed. This is what major companies do. So for the utility scale, it's usually not the problem. But for commercial, industrial, residential, people maybe do not look at the full picture. And this is extremely important for us to let them understand that even if the premium is around 2, 3, 4, 5% extra for the modules, which means that it's half of it for the whole project or less than that. So we're talking about 1, 2, 3% extra investment in the project, but it completely makes financial sense along the lifetime of the project.
Yeah, so I think this is very important, Walid. So scientists, we always test understanding testing conditions, which is completely unrealistic in the field, but then it was very important and very nice to see from you that also we have these other gains that we don't see in our standard testing conditions, such as temperature coefficients, bifacial degradation, and so on, which gives you an additional input and an additional advantage which you don't see in the lab when you only optimize versus error and versus efficiency.
Yeah, and this is exactly what we try to do at PMApping every day, connecting the industry with the scientific community, which we can see today. It's very interesting. It results in big achievements at industrial level, but also at academic level. So thank you very much for being with us again. It was a great contribution. It was a great discussion. Hope to have you soon in another webinar. And thank you to all the participants for the questions, for actively participating to the event. And let me remind you that there will be other P-Magazine webinars in the weeks to come. So just stay with us and look at our event page for the next webinars. Thank you again for being with us. Thank you for joining, and see you next time. Bye.
Bye.